Okay, in this video, we're going to show you how to import drone or LiDAR data into AgForm 3D. But before we get started importing, you got to get some information ready. I got some drone data from a person I know up in Northeast Arkansas as one example. And he was using the drone and had propeller arrow points out in the field. And so he sent me that data. So the first thing we need to do is look at the data and you can see the reference system, which is NAD83 2011, the EPSG code, which helps give you the state plane coordinates, and so projected coordinate reference system is this state plane coordinates. The NAV-AD height in the geoid model is geoid 12B, which the current geoid model now is geoid 18. But anyway, this gives you all the information, you know, the date and everything. We have the the latitude, the longitude, the ellipsoid height, the northing, easting, and the orthometric height. Typically, we're going to bring in the orthometric height is what we're going to use. You can bring in the ellipsoid height data, and I'll show that. But so we have to get all this information ready, and these are points that the propeller points, but you can also use these as benchmarks, you know, for ground truth and actually setting up on the field if you use this data to actually level it with. So we have all this information, and I've got all this set up in some different files so that we can import it into AgForm 3D. And what we have the, let me just get all up here. Okay. First off, this is the state plane coordinates. You can see we have this is the northing, this is the easting, this is the elevation. We have BM1, BM2, BM3, and all this data was taken from down here. So whenever you import in data to AgForm, you give it some coordinates. You don't have to use these state plane coordinates if you want to, but you have them, so why not? Then we have the local benchmarks in a latitude and longitude. This is what we'll use to import the data in latitude and longitude. AgForm uses WGS84 projection for whenever they're doing surveying, so that's what they use when you bring data in. I do have this data in a state plane coordinate system. Had an issue bringing it in. Apparently, it could be from a projection issue, state plane coordinates versus latitude, longitude, and I'll show you an example of how it came in at a slight error. So, but it's best just to use latitude and longitude. Then we also have the latitude and longitude with the ellipsoid height, which is what we got from down here. So I'll show you how to do the using ellipsoid height if that's what you want to use. But you know, primarily you're going to be working in mean sea level elevations. So I'll show you all that. And then we have the data that will be brought in. I took the state plane coordinates that I was sent and put them into another program and corrected them into latitude and longitude so that they come in properly. But this is all the data. So we will work on this. So first off, we go into AgForm. We will create a new project, and we'll just call this project 3 for right now. You see this geoid file is set to geoid 2012 BU7, and this is an older geoid file, but that's what the propeller points were using. And so that's what we'll set that to. It's not detrimental that you have to use this geoid file, but it does add a little bit of accuracy to your data when you're out surveying and everything. So we have here the, you know, right now I set the northeast elevation, which is kind of defaults for what I use when I'm surveying. So we want to use the state plane coordinates. So we'll go back down here and find the state plane coordinates for this project, and you can see that we have them here. So we can just copy this. Our northing, this is our easting. And this is our elevation for our benchmark. So then we just click OK, and it pulls in a benchmark, and we go to the field menu and look at it. Click on Edit. You can see we have our northern, eastern elevation there, but we have no latitude, longitude data. So what we do next, well, we're going to import these benchmarks with the latitude and longitude data. So click OK, and we're going to do the ellipsoid first, which will be these. So we go to Exchange, Import Field Data Points. We'll choose that file, latitude, longitude, ellipsoid. Click Open. Now then, looking at this, we have our latitude first, our longitude, our ellipsoid height, and then the benchmarks. So whenever we're choosing what kind of data we want to bring in, we're going to choose geographic coordinates. So we have latitude, longitude, and elevation, but we also have an identifier over here, which is these benchmarks. So we have to add that, because if you don't add this identifier and you bring in the points, it'll bring them in, but it won't have the identifier, or it may not bring anything in since there's no identifier. And in this case, we are using the ellipsoid. So here we have our ellipsoid elevation, so we have to choose ellipsoid heights as opposed to local elevation. If you choose the wrong one, it'll give you an error on your benchmarks versus the data that you bring in. So we have this here. We have latitude, longitude, ellipsoid height, and benchmarks. And we don't have a header line, and we're not comma delimited. We're white space delimited. So if you get data that is comma delimited, you would need to choose comma delimited. And if there's a header line that may say, like, latitude, longitude, elevation, description, you click on Skip Header Line, so it won't try to read that first line, because you'll get an error message. So in this case, we just use white space, ellipsoid heights, geographic coordinates with our identifier, which is this. So we import interior points. We're not doing that. There are no interior points. We're mainly just bringing in benchmarks. So we import master benchmark, BM, identifier prefix, MB, and secondary benchmarks, BM, with identifier profile, BM, which all of these are BM. So we don't have to have this checked, but if there's nothing there, it's not going to bring anything in. So we click OK. So now we have to add the latitude and longitude. So we just copy, paste, do our longitude, and then do our ellipsoid height. In this case, it's 142.095. So now if we go to our field menu, list our benchmarks, we have them. This one was already created when we first started the project, so you'll actually have two BM1s. But if we click on Edit, so we have our northern, our eastern, our elevation. Down here is doing a conversion. We got our latitude, longitude, and the ellipsoid height. And we have the geoid undulation because we're using that geoid file. And so it tells us that our mean sea level is 234.41, which equals this. Now, in this particular version of AgForm, which is the latest one that's out, they made an error. somehow or another, because it didn't do this before when I would bring in data. But if when you're importing, if you choose local elevations, it's not choosing the local elevation. It will make this the local elevation, which causes an error down here, and I'll show you that here in just a minute. So we click OK, and we have the other benchmarks that have all the latitude, longitude information with them. So we just click OK, click OK. Then one way you can tell that you've got everything, if you go up and turn on your Bing Maps, there's your field where the data is going to be brought in. And the data that's going to be brought in will be in this long triangle right here next to this ditch. So now then we can, I'm going to undo all of this and then bring in the, show you how to bring in the mean sea level elevation. So I just do a Control Z. Let me get rid of this. So now then, go back to Exchange. We'll do our points. And this time we're going to do the local elevations, which will be latitude, longitude, local benchmarks. And we choose local elevations. Same thing here, same file. Let me find that. So you can have, here we have latitude, longitude with local elevations. So we're going to, nothing changes down here. All this is the same. We just keep everything as is. So we click OK. So now we have to copy and paste this information. You see here we're putting in our local elevation, MSL. But see down here it still says ellipsoid height. Previously, when you chose local elevations, this would say local height. So there's an error in there. So when it does this calculation, even though you punched in local elevation, it's calculating it based on it being an ellipsoid height. Then I'll show you what kind of error you'll see. So we click OK. Same thing here. We got our benchmarks. We go to the field menu, click on List. Now then, see, we've got our local elevation here, which is good. But see, it's showing the ellipsoid height is 234, and it's converting it to a mean sea level height of 326.72, which is not correct. If you needed to know the actual ellipsoid height, you would just subtract this geoid undulation from this number here, and it would give you that ellipsoid height that we had in the first import. So it's, you're going to get your elevations as correct. So all that's good. And this is just going to affect mean sea level height of what this showed in the master benchmark. So we click OK, and see this master benchmark we brought in, it's still 234.41. And then we have all the others here. And so this is what counts here. If for some reason or other you wanted to change a benchmark to the master benchmark, you can just choose it, hit set master, and it'll ask you a question and just say yes. So now BM2 is your master benchmark. We're just going to go back to the first one. Click OK. So now then we click on this. See, now we've got our field back. So now then we're going to import the actual survey data. So we want this here, local drone data filtered. So which has been, actually this data that I was sent was unfiltered. It hadn't been, the raw ground hadn't been extracted from it. So I filtered it somewhat in another program, so that's what I'm bringing in. So we click open, And if we look at this, here's our data here. So here we have just latitude, longitude, elevation. But over here we have latitude, longitude, elevation identifier. And so we don't have an identifier here. So we will need to remove that. And then geographic coordinates. And I typically use decimal degrees for latitude, longitude. It just seems to come in better. And then we have local elevations. Same thing here. We don't have a header line, white space delimited, not comma. All this will stay the same. Now, one thing, if for some reason or another you bring in some data that is out of order, let's just say sometimes you get some XYZ or longitude, latitude elevation. If we move this and make that first, even though we're bringing in latitude, longitude, if we click OK, see, it throws us off. It puts us somewhere else in the world. Or you'll get an error message saying that the master benchmark is more than 6,000 feet away. So we would undo that, go back here. So now we're going to bring in this data again. And we're going to change this back to the way it's supposed to be. Latitude, longitude, elevation. And now then we have drone data or LiDAR data, either one, whether it's from photogrammetry or LiDAR, gives you a lot of points. In some cases, more so than what the program can handle, or it'll be sluggish in handling that data. So if you want all that data, you can choose all points, and I'll show you a file of the same file with all the points. But in this case, we're just going to do a sampling data of every 25 feet. So it's going to cut out a lot of the data that we don't need, and you'll notice a difference between the contours, the existing contours between all the points and the sampling data. So we click OK, and now we have all the data. So we'll turn this off. You can see all the points that we've got. So now then we'll hit the F4 key, which is the regenerate contours, or if you go to the field, it's this button here. See, it says F4, so we're just going to click on this. And we're going to change this to 50, because I think the lowest number you can go is, we can't do 25, because I think the lowest is 32. So we'll try 25, see what we get. It says enter number between 32.8 and 1640. So we'll just do 50 and click create. So now then, there's all your data points. And we'll turn these off, and there's your contours. And let's see if we see how it comes in. So if we look up here in this corner, this is the edge of the field. This is the edge of the field, so everything comes in correctly. So, but I want to show you, if we're bringing in that state plane coordinates, I had another file. This is where all the points are. You can see that the edge here should be over here, but it's not. So there's a slight projection error by bringing in that state plane coordinates that may have happened on the export of the data. But so anyway, it's just best to bring in the latitude and longitude. So also look at the difference in the contours. Let me click on this one. We'll come out a little bit. See how they're still jagged, but they're not as noisy as what the other is. So if we click on the one, this is one where I brought in all the points. So here we have, let's see, how many points is in this one? Here we have 2,945. Here we have 27,531. And you can see from the points, turn this off, how close they are. So you get a lot of noise and all this, so you're getting a lot of small contours that really just kind of gives you a hard time of seeing how the the field lays. So if we go back to here, you can see a difference in all this. So that's bringing in that data with fewer points. So it gives you smoother contours and everything. So and also bringing in the latitude, longitude, gives you a better chance of ensuring that your projection is correct and it brings it in properly. So I'm going to bring in another one now. And typically you would have your ground truth points spread around. These are all down here in this corner. It may have been too wet to get out in the field, or for whatever reason, I'm not sure. But typically you try to have them spread around. So now we're going to do I'm not going to save this. We're going to do another one. Let's call this 4. You click OK. You find that file. Okay. Okay, this is another field. This is just some LiDAR data that I downloaded from a website. So we can bring these in. We'll do an exchange, import points. Let's see here. I need the part. Need the state plane coordinates. Here they are. All right, let me just go back, and we're going to change these coordinates. Our master benchmark is these coordinates here. So click OK. So here's what we want to bring in is the latitude, longitude benchmarks. So we go to exchange points. So now we got to add the identifier back in because we have the benchmarks. So we go identifier, add, and we're latitude, longitude, elevation, local elevation. That's what we got. All this stays the same. All this stays the same. So we click OK. So now we have, close this. Okay, there's our benchmarks. If we go up there and turn this on, our Bing maps, and you can't see them, but they're there out in this area here. So now then we want to bring in our data, our LiDAR data. So we don't have an identifier. So if we look at these, see we're just, let's see, these are state plane coordinates. Large file. Now, latitude, longitude, see, and no descriptions or identifiers. So we will remove that, and they are local elevations. So we choose local elevations. So now then we're going to keep with the sampling interval of 25. So we click OK. Oops. Now, since we had already got our latitude and longitude in through the benchmarks, we didn't have to copy and paste those latitude and longitude points. So if we turn on the points, here we are. So we press the F4. I want to show you something else. I'm going to set this to like 100. So if you ever have to do some trimming, click Create. And see here we have 8,715 points. We'll turn these off. Go up here to our options. We'll put this on 2 feet. So they're not so crowded and they're still close together. You can see there's a lot of elevation changes in here. Now, you know, these are points that I created just from this data. But assuming you had, you know, other type of ground truth points out there, that would be you could convert those to benchmarks. So here we have, you know, you have your elevations at each of these points. So now if we want to see what the ground truth is, all these are going to show 0 because I copied the points from here. So we go up to Home, click on Design, and just do Matched. And this will create a design surface that matches the existing elevations. So if we turn off the existing contours, now we have design contours, which are exactly the same as the existing contours, but now we have cut and fill. But we have 0 at, you know, each one of these. Now, if you had set these with the, you know, your GPS system before you flew, then whatever the GPS system came up with, once you hit that match design, it would tell you the difference between the LiDAR triangulation and the point that was actually set. So you'd kind of get an idea of what your ground truth looked like compared to your actual LiDAR or photogrammetry elevations. So, but one thing I wanted to show you, I got to get rid of the design menu. So we'll go back and turn these points on. So now we're back to the raw data, no section design. You can see how when I hit that, use 100 to connect all these together, we have a corner that was jumped. We can trim this corner, and this, you know, we don't have anything else. This is just that one corner. But if you get an irregular shaped field and you need to do this, what you do is go over here to your layers and turn on the triangulation. So you can see how all the triangles were made. But see, we got a couple extra triangles because we set that to 100, so it jumped from here up to here instead of going to these closest points in this curve. So what you want to do, press the Control and Shift, and we're going to go over and choose the this selection polygon, press Control, Shift, click once, okay. Click, draw the line, come back out, connect it. Whenever it connects, connect it, then let go and press delete. And now we've fixed that corner. So let me undo that. So come over here and choose your polygon selection. You could also use this one here too, if you have, but if you're in some tight spots, you know, the selection polygon here works better. But if we just come up here, press Control and Shift, click and hold to grab those lines, let go, and then press delete. Does the same thing. So now we've squared up this corner here. And there's another function that you may or may not want to use, but I'll show it to you. So if we go up to the field menu, as you can see right now, all our points are interior points. So if I turn these off, they all go away. So we turn these back on. So now we have move to perimeter. And it says move interior points on the topographic surface boundary to the perimeter layer. So we can click on this. Now then, we just turn that into a perimeter, and we have perimeter points. So if we turn on the perimeter, now we have these. These are separated from this here. So, you know, you may or may not need to use it, but if ever you wanted to just export this perimeter line, then you could turn these off and just select all, you know, go into exchange points, and you can, let's see, wrong one, go to export, and you could choose export perimeter and to give them a capital B or whatever kind of identifier you want. So you could export, but you would need to uncheck everything else because it's going to, you know, choose everything that's there. So we just uncheck these, and then you can do it by point number, northeast elevation identifier, or you could also use geographic location, you know, coordinates, and do the latitude, longitude, ever what you need to do here. So we're just going to cancel that. But anyway, there's just some options that you have. So we turn off these points. I said we have our, see right now, our surface. This is our existing contours, and under we don't have any design. So if we turn off the existing contours, we go back up here to home, click on design and matched. It'll add the section line, the section, and now we have our design contours turned on, and it shows the difference between the contour surface and your ground truth points. In which case, like I said, I made these so they're 0 everywhere, but whatever your GPS ground truth points are, this will be a comparison between the surface and your points. So, and you can then you can start doing your designing from this or whatever you want to do to, you know, build whatever project you're building. So anyway, that's just ways to bring in LiDAR or drone data, depending on what your drone is, whether it's photogrammetry or LiDAR, but also even LiDAR from the government websites for doing just preliminary work. I do a lot of that for people that, you know, they want duck hunting, you know, elevations and things like that. So, but, you know, this is one way to bring it in, and you can give it to your clients. So that concludes this video.